जीत सर को बोल दो कि शेयर कर दे, तुरंत बोल दो. Hello everyone. Am I audible? Good evening, Hemant, Abhijit, Naveen, Srajal, Anmol, Keshav. Hemant, travel कर रहे हो? Okay, good. So we will start once 100 people come live. They are about to join. Good evening, Utkarsh. Good evening, Rijal. Good evening, Harshvardhan. Just wait for 2 more minutes. Great. So, very good evening to all of you. And today we'll be doing something which has never happened in the history of CAT, GMAT, or any kind of aptitude preparation ever. Neither in India nor in the world. Today I'll be discussing Brahma Triplets and my approach to solve those triplets. So when I was a kid, I think some of you might be knowing it. When I was a kid, I was playing with numbers, and while doing that, I came across a lot of observations, a lot of theorems. So initially they were hypotheses, and now they have become laws, or you can say theorems. So I formulated close to 100 theorems, out of which 9 are very original, and that comes in a book called Brahma Ganit. So I'll be discussing one of those theorems which will be very much applicable for your aptitude preparation. All right. So look at this slide. This is Pythagoras. And Pythagoras is someone whom I consider equivalent to God. Seriously. So he was such a famous and such an important figure in the history of mathematics that he should be considered next to God. And this is something which is absent in the mathematics delivery across the colleges and institutions and universities and coaching institutes as well, that we people, when we teach mathematics, we just teach the questions, the theorems, the formulae and all, and the students do not actually understand the meaning of mathematics, the logic behind any theorem, or the importance or significance of any theorem. Except mathematics, whatever you study, you will be getting a historical perspective of everything, but in mathematics, that is absent, and that is something where I come from, and that is something which I will show to you, so that your logic is developed on your own, and you won't be always dependent on the theorems, but you will be more inclined towards finding a logic towards any generalized mathematical observation. All right? So let's start the class. Give me a thumbs up so that I understand that you guys are listening to me and paying attention as well. Great. So the session starts with a very famous quote from Pythagoras. He says, "Give me an infinite number of right-angled triangles, and I shall create the entire universe." Yeah, sounds strange, but that is true. After the session is over, you'll also start thinking the same. That right-angle triangles are actually the building blocks of entire universe. That is what Pythagoras believed, and that is what he proved. And because of his contribution to mathematics, we developed a stream called trigonometry. Trigonometry is totally dependent on theorems of Pythagoras. So welcome to this class. This class is called as Brahma Triplets, and we'll be discussing a modern approach to Pythagorean triplets, that is by me. So here goes the first slide. Okay, so you can see a square over here. There is a square, right? And I want to somehow derive the Pythagoras theorem. So I was thinking that what were the different ways of proving or deriving the Pythagoras theorem. If anybody of you know it, then it's great. In case you don't know, here we'll be discussing it. So you can see a square here, and I'll just put another square in a tilted way. Cool. So look at this. Now we have another square, which is put inside the larger square. And here I have done something. As you can see, because it is a square, a symmetric figure, a regular figure, so if you put this inside, that means the larger, I put in such a way that there's a larger side and a smaller side. So I think you all are aware, and you all can imagine and observe that all the longer sides, like this side or this side, and this side, they all will be same. Similarly, the smaller sides will be equal, right? That is something which I think all of you can really understand well. So I have done one thing. The larger sides, I'm calling them P. As you can see on the slide now, let us call them P, and P will be denoted by, P is basically the perpendicular, which of course all of you know. So I have mentioned the larger side to be P. Then the smaller sides, let them be B. All right. Now the square which is smaller, let the sides be equal to H. Cool enough. Now what do we have? We have a larger square and we have a smaller square. The smaller square is orange in color. The larger square was initially white in color, but now it has two colors. One is of the smaller square, that is orange. And there are four equal triangles, and all of them are right angled. All right. And they are equal triangles. So if I want to find the area of the larger square, as you all are aware, that the area of any square is basically square of its length of the square of the length of its sides. So side of the larger square is P plus B. Okay, P plus B whole square will be the area of the larger square. Area of smaller square will of course be H square. Again, the side is H. And area of the four triangles, the four white parts, the white triangles, as we can see, is basically 4 multiplied by half into base into height. The base is base and height is perpendicular over here. So this 4 multiplied by half multiplied by PB. Okay. What next? So area of 4 triangles, if we solve it, 4 and half gets cancelled, becomes 2. So it is equal to 2PB. Now I can also say that the area of the larger square is the sum of area of the smaller square plus area of the 4 triangles. That is quite evident. Such a simple method to solve this. Okay. So once I do this, area of larger square is equal to area of smaller square plus area of 4 triangles. The larger square is the area of larger square is P plus B whole square. Area of smaller square is H square, and area of 4 triangles is 2PB. Now what if I open this bracket? What do I get? I get P square plus 2PB plus B square is equal to H square plus 2PB. B. As you can see that from both the sides, 2pb can be cancelled out. And now what are we left with? We're left with p square plus b square is equal to h square. That is what we are left with, and that is what is called as the Pythagoras theorem. Right? I would give you some time, a few seconds to absorb this information. How beautiful this is and how easily we have come to the derivation of Pythagoras theorem, a theorem which changed the entire course of mankind, a theorem which developed trigonometry, in turn developing engineering, bridges, roads, all the construction, all the pillars, all the monuments that we see, it's all dependent on Pythagoras theorem. So that is how important this theorem is. Right? Okay. Now we'll be discussing Pythagorean triplets. So, the Pythagoras theorem, as we know, is just a minute. P square plus b square is equal to h square. Now, if I use a similar expression and I use a variable over here, so let me say that there are two variables, the sum of whose squares is equal to another perfect square. Okay, there is one thing to be very sure of. When in the time of Pythagoras, in the era of Pythagoras, only natural numbers existed. And that is why they are called as natural numbers, because they exist naturally. Things can be 1, things can be 2. So normally at that time, and before Christ era, at that time, negative numbers or 0 did not exist. So this expression was basically applicable when ABC all belong to the set of natural numbers. At that time, there was no nomenclature as natural numbers, but now, in 21st century, we can say that. So ABC belong to natural numbers, and A square plus B square is equal to C square. So if any three variables satisfy this expression, then those variables, if represented inside a set, would be known as a Pythagorean triplet. A Pythagorean triplet. Cool? Okay, Sahil asks, is this the actual proof or your method? Sahil, there are more than 100 methods to solve this. This is the easiest one, so that is why I chose it. So now I think all of you have understood that what is the meaning of Pythagorean triplets. Now, I want you guys to mention some triplets that you already know. Mansha says 5, 6, 7. No, Mansha, 5, 6, 7 is not a Pythagorean triplet. Okay. Sahil, you have a smaller proof. That's great. There are 150 different proofs. You can share your proofs with all of us. That will be really enlightening. The smallest Pythagorean triplet is 3, 4, 5. Yeah, right. Right. So 3, 4, 5 is the smallest Pythagorean triplet. You can check that out. 3 square is 9. 4 square is 16. If I add them up, I get 25, which is equal to 5 square. This is one of the triplets. There can be more triplets like that. Hemant says 4, 6, 10. No, Hemant, 4, 6, 10 does not satisfy this equation. 6, 8, 10 actually satisfies. You're right. Naveen says 24, 7, 26. No. Rijul says 1, 1, square root of 2. No, Rijul. As I mentioned, that Pythagorean triplets are always natural numbers. 5, 12, 13, of course. Okay, there's one thing I want to tell you. There are, 3, 4, 5 is a Pythagorean triplet. And if I multiply this by 2, I get 6, 8, 10. This will be satisfying this equation, but that won't be called as Pythagorean triplet because it is basically we call them derived triplets. Okay, so if you multiply this by 3, I get 6, 12, and 15. Again, this is a derived triplet. The original Pythagorean triplets, they have their HCF is 1. There's no common factor over there. All right. So 6, 8, 10 is a triplet, but it's not a trivial Pythagorean triplet because the HCF is not 1 over there. I think you got it. Okay, coming on to more triplets, like someone said 5, 12, and 13, perfectly right. 7, 24, 25, perfectly correct. 11, 60, and 67, and 61, that's perfectly fine. 1, 9, and 12, no Bharat, that's wrong. If you check that out, it will be wrong. 9, 7, 16 shells, no, 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 no. See, 9 plus 7 is equal to 16. We are talking about the squares. 7 square plus 9 square is not 16 square. All right. Pranshu, 9, 12, 15. Oh yeah, I'm so sorry over here. Doesn't really matter. That's 9. So, if I talk about the trivial triplets, you know, the real triplets, just a minute. All right. 3, just a minute. 3, 4, 5, 5, 12, 13, 7, 24, 25, and like 11, 60, and 61. They can be many triplets. Now tell me something. If I ask you, Rachel, no, not generalized form, that is just one. 3x, 4x, and 5x is basically the multiples of one triplet, that is 3, 4, and 5. There can be n number of triplets. Now, the question over here is, what if I tell you only one number? What if I tell you only, okay, from these 3 elements, I tell you only one element. Let's say I tell you only 11. Would you be able to find the other 2 triplets, other 2 elements of the triplets? Is that possible? Now, look at the problem. The problem is that we have an expression called a square plus b square is equal to c square. There are 3 variables. And generally speaking, if we know 2 of them, we can find the third one, right? But is it possible that I know only one of these, either A, B, or C? Like knowing A or B doesn't really matter. It's basically sum. So I know either A or B, or I know C. So is it possible that I can find the other 2? Is that possible? Sahil says yes. Keshav says yes. Pranshu says yes. Raghav says no. Shell says no. Cool. So this is why you are here, and this is what I'm going to teach you, that even if you know only one element, you will be able to find others as well. All right? Cool. Let's do that. So I think this will be kind of really exciting. So tell me if you're excited to know the theorem through which you can find the other 2 numbers if you know just one. If you're excited, just show me a thumbs up. Okay. So the method or the theorem through which we will be able to find this is called as Brahma Triplets. That is the name of the session today. So what we'll do over here, the Brahma triplets are basically, I'll write first triplet, n square minus 1 whole upon 2, n square plus 1 whole upon 2. Please bring out your pens and papers because this is very important. You need to note this down. This is going to blow your mind, and really this is going to help you more than anything else can. This is the triplet, and this can be used only when n is odd. All right, only when n is odd. No, Pranshu, that's not the correct expression. This is the correct one. So we'll be using this if n is odd. What if n is even? In that case, we'll be using the second bracket. So if n is even, the triplets will be n square minus 4 whole upon 4, n square plus 4 whole upon 4, as you can see from the slide. Now let's try this out. Are we able to calculate the triplets over here? I want you to try this. Do that. Put the values. Pick any odd number, even number. Just try to put it over here. Are you able to find the triplets? And tell me if they are correct. Let's do that exercise. So let us try to put n is equal to 3. If I put n as 3, n square minus 1, this should be the triplet. Let's solve this. 3 square is 9 minus 1 is 8 whole upon 2. Similarly, 10 upon 2. If you solve this up, you will get 3, 4, and 5. That is the smallest triplet that we get. Right? Okay. Let's put 7. Let's try to put 7. What happens when n is equal to 7? 7. Then 7 square minus 1 whole upon 2. 7 square plus 1 whole upon 2. If we solve this, we get 7. 7 square is 49. Minus 1 is 48 whole upon 2. Here we'll get 50 whole upon 2. This comes out to be 7, 24, and 25. Someone mentioned that triplet. So now we can find any triplet we want to. Right? Harshvardhan tried to find out 13. Harshvardhan, 13 and then 84. And then 85. Good. You can check this out. Now let us take an even number. Let us put n is equal to, so sorry. Let us put n is equal to 10. Now 10 is even. Okay. So if we solve this, okay, Devi Prasad has already solved it. 10, 24, and 26. Yeah, right. So we are getting another triplet, which is actually a derived triplet of 5, 12, and 13. Cool. Let us put n is equal to 20. So n is 20. Then we have 20 square minus 4 whole upon 4. And we also have 20 square plus 4 whole upon 4. 20 square is 400, minus 4 is 396 whole upon 4. And we have 404 whole upon 4. Now, if you solve it, you'll get 20, 99, 101. I hope this is clear. Right? 20, 99, and 101. So triplets for 20. So basically, if we try to make a right angle triangle with one of the sides, the smaller side says 20, the other two sides will be 99 and 101 each. Right? So we can go to any limit we want to. For example, what if I want to put n is equal to 99? Well, that's a huge number. We'll get 99, then 99 square minus 1 whole upon 2, and 99 square plus 1 whole upon 2. Right? The square of 99, in case you don't know, is equal to 9801. This is the square of 99. Now if I solve this, I'll get 99, 9800 whole upon 2, and 9802 whole upon 2. Isn't that cool? I'll get 99, 4900, and 4901. How cool is that? Good. Raghav says, what if we don't have the smaller side? We'll come to that, Raghav. Great. When perpendicular or base is known, that is what we have already done. we are able to find a lot of any kind of triplet if the perpendicular or the base is known. Basically, n is known. So what is n? N can be perpendicular or the base. The problem here is, what if we know the hypotenuse? What if we know the hypotenuse only? Are we able to find the perpendicular or base? Is that possible? Is that possible? Okay. So let us say someone tells you the largest side of the of any triangle is, let's say, 5. This is the largest side. So as we know, the formula is this: n square minus 1 by 2 and n square plus 1 by 2. For odd and for even also, I've told the formula. So I think this is very easy and no prize for guessing if I directly say that we can equate the largest side to the this or this, and solving for n we can get the value of n. Clear, right, Bharat? Perfect. ये फॉर्मूला कहाँ से आया? ऋषि कह रहा ब्रह्मा से. Okay, I'll tell derivation as well in some other class. Let us now look at the utility and application of this theorem. Exactly. So this is what we can do. All right. Now let us move further. There are much more exciting stuff in this class. But before that, I want you to solve a question. This is a very easy question. As I said, a very easy question. Find the integral solutions. Find the integral solutions of the equation x square plus y square is equal to 20. Let's do that. Gaurav, yeah, if random side is given, first of all, we'll use it as n and we can get the other two values. Okay, if it is not, and we can also equate it to the largest side and we can get the value of n. So basically, what we get over here, that's any side, any number n. They won't be asking you that, okay, tell me the sides of triangle. The questions will be in this format, okay? This looks like an algebra question, but it's basically a geometry question. So if any random side is given, that means we can calculate the other two triplets, assuming them to be perpendicular or base. And we can also find a triplet, assuming it to be hypotenuse. So what we get from here, any particular number can be a perpendicular as well as a hypotenuse. Okay? But at the same time, all the numbers are not necessarily hypotenuses. Clear? So there are many numbers which cannot be hypotenuse, but all the numbers can be perpendicular or the base. I think it's clear. I'm repeating. Any number can be a part of two different triplets, one time as a perpendicular, other time as a hypotenuse. Okay, so maximum they can occur in two triplets, and minimum they can occur in one triplet, that is as a perpendicular. Right? So let's solve this question. Find the integral solutions of the equation x square plus y square is equal to 20. Okay. Anybody, I think some of you might be knowing that this equation, if represented geometrically, will form a circle. Isn't it? This will form a circle. Right? Great. So 2 and 4, of course, is possible that you have calculated. And as it is a circle, like I have just shown over here, so we will always get 4 integral points. That is something which we will always get. This will be 20 comma 0. This will be minus 20 comma 0. This one will be 0 comma 20. This one is 0 comma minus 20. So there are 4 points which we will always be able to get. I mean, ये equation of circle है. Equation of circle where the origin is 0 comma 0. This is the origin. Okay, and square roots, irrational numbers are not will not be the solution. The question asks about integral solutions specifically. Okay. Cool. Now, how do we use triplets over here? If you look at this, x square plus y square is equal to 20. The method to solve these questions is these 4 points would of course be there. That will always be there. Okay? These two are perfect squares. This is not a perfect square. But do we have any factor of 20 which is a perfect square? It is root 20 here. Okay, so what's the problem? Okay, x square plus y square is equal to r square is the equation of a circle. So it's all right. The radius is root 20. That means this is not possible. Cool. I'm really happy that you guys actually can see this. Nicely done. Very good. That means these are not possible. They are basically roots. This is of course not possible. Negative root is not possible. Well, so how to solve this question? Now, look at this. X square plus y square is equal to 20. These two are perfect squares. This is not a perfect square. But do we have something? Do we have any factor which is a perfect square at a factor of 20? 20 can be written as 4 multiplied by 5. And 4 is actually a perfect square number. That's correct. Now, what if I take 4 out, 4 common? If I take 4 common from here, what do I get? People are commenting 4, 2, 1. It's not 2, only 1 and 4. 4 and 1. Okay. Five. Siddhant, we get 5. Right. Perfectly fine. So now to solve this, what if I what if I what if I assume x to be x to be or x square to be 4a square and y square to be 4b square. Why I did this? Because I want to take 4 common. I want to take 4 common. Once I do that, what I'll get over here? I'll get 4a square plus 4b square is equal to 4 multiplied by 5. Now I can cancel out 4. I'll get 4 times a square plus b square is equal to 4 times 5. And both the 4's will be cancelled out. So I get a square plus b square is equal to 5 over here. Now once I have done this, I'm sure that 5 is not a perfect square, so any Pythagorean triplet will not be following it. So we are left with only 2 options, that x is 2 and y is 4. At the same time, negative values are also possible. Once said that, how many possibilities do we have? 2, 4 is one of the possibilities. Minus 2, 4 is also a possibility. 4, minus 2 is also a possibility. And minus 2, minus 4 is also a possibility. So overall, we have 4 possibilities here. Is that clear? Because integral solutions are asked, so we can have the negative values also. Overall, we have 4 solutions here. Okay, do we have more solutions? Do we have more solutions? Well, 2, minus 4 is also possible. So if I keep 2 fixed, I have 4 solutions. If I keep 4 fixed, I have 4 more solutions. Like 4, 2. 4, minus 2 is already written over here. Minus 4, 2 and minus 4, minus 2. So whenever we get one pair, and because we can exchange the values, so for one pair we can get 4 different solutions. So basically, we'll have 4 solutions when x is 2 and y is 4. And similarly, 4 more solutions when x is 4 and y is 2. So overall, we have 8 solutions. All right? Is that clear to everyone? Okay, there is a question coming in. What if we had a perfect square in place of 20? Yeah, that will be the next question. I've discussed that as well. The next slide, I'll be discussing such question. Is this clear, everyone? Hit a thumbs up so that I know it's clear to you. And we'll move on to other question in which I'll be using a perfect square here. Okay, Raghav. Okay, Shells. Cool. Look at this. Find the integral solutions of the equation x square plus y square is equal to 25. Raghav, what happened? Not clear? Now this will be clear because I have used the perfect square here. Yes, Devi Prasad. So this is what we were discussing. The previous question was basically we can find the solution just by putting x is 2, y is 4. It was a simple number. But whenever we have a perfect square over here, we can go for Brahma triplets. And that is where the application of Brahma triplets comes in place. Rakshita, in that case, there will be no possible solution. If factor doesn't have a square number. All right, Rakshita? And that is the reason there is no possible triplet. Okay? This will be more clear once we solve this question where I have used a square term in the right-hand side. All right, Rakshita, hit a thumbs up. So if we can move ahead. Okay. So first of all, let us draw a square. Now this square, sorry, the circle. This circle, the radius is basically 5. As we know, x square plus y square is equal to 5 square. So for sure, we'll be getting 4 points. Why? Because we have a perfect square over here and radius is a natural number. So now we have 5, 0, minus 5, 0, 0, 5, and 0, minus 5. So these 4 would always be there. But in addition to these 4, there can be other integral solutions as well. And that is possible. Why? Because this 5 belongs to Brahma triplets. This is the ideal scenario of Pythagoras theorem. So now we have got, this is 5. So a triplet is 3, 4, 5. I have used a simple number, 5, because to make you understand, I have used a simpler number. But even if the number was a larger number, we could have found out whether it lies inside the Pythagorean triplet or not. How? By equating this part to the largest part. I think this is clear. Right? So this part, if I equate to the largest element, this one, and if I equate this to this one, and I get a natural solution for n, that means this will definitely be a hypotenuse. In case we don't get it here, we can equate it to n square plus 4 by 4, as in the case of human. So, if this radius, if this 5, we equate to this or this, and we get n as a natural number in either of the cases, that means 5 is definitely a hypotenuse. Okay, so for the larger number, we can do the same. In the next question, I have used a larger number. Cool? Okay. So now, having said that, we have got 4 solutions already. 1, 2, 3, and 4. There will be more solutions because 3, 4 is one of the cases. Now, as 3, 4 is a case, we can have minus 3, 4. We can have 3, minus 4. We can also have minus 3, minus 4. Similarly, if we reverse it, we'll have 4, 3, minus 4, 3, 4, minus 3, and minus 4, minus 3. So here we have 8 more solutions. So overall we have 4 plus 8, that is 12 solutions for this. So where do the Pythagorean triplets help? They help us to determine whether this part is a hypotenuse or not. If it is a hypotenuse, let us generalize this. If this is a hypotenuse, we will surely have 12 solutions. Cool enough? For next time, if this question comes in CAT or any other exam that you sit in, always try to find whether this is the square root of this is a hypotenuse or not. If it is a hypotenuse, directly mark 12 as the solution. Is that clear, everyone? We have generalized such questions now. Hit a thumbs up in case it is clear to you. We'll always have 12 solutions if R is a hypotenuse. If the radius of a circle is a hypotenuse, we'll always have 12 solutions. Hit a thumbs up and then we'll move on to the next question. Cool enough? So do you think we have kind of generalized a difficult question? Not a very difficult question, but of course, you might have taken 3 minutes to solve this question, but now you'll take only 3 or 4 seconds, might be 10 seconds, not more than that. Raghav, it's exactly 12, not minimum 12. If it is a hypotenuse, it's exactly 12. हर्षवर्धन 12 कैसे हुए? 8 ये वाले और 4 पहले वाले जो यहाँ पे लिखे थे हमने. ये 5, 0, -5, 0, 0, 5 and 0, -5. So four solutions are on the axis, y-axis. Positive y, negative y, positive x, negative x. 4 तो ये होंगे ही होंगे और 8 और हो जाएंगे. Clear? Good. Now a difficult question, and this is actually this is the most important question of the session, and this is actually a CAT level question. You can expect such questions in CAT. The questions that we discussed before this were basically for concept building, but the kind of question that you can expect in CAT is this. So let us solve this. You have 2 minutes to solve this. This is a circle, right? That is for sure. And is this a perfect square? Yeah, 53. Nice. So you guys have found out that x square plus y square is equal to 53 square. Now, I'll be quickly revising everything that we have discussed over here. So once we are able to find the exact equation of the circle, after that what comes, we'll have to check whether this is a hypotenuse or not. Whether this can be a hypotenuse of a right angle triangle or not. If it is a hypotenuse, the answer will be 12, as we discussed. If not, the answer will be can be 4. It can be 4. Om says 12 solution. How is that possible, Om? Have you checked this is a hypotenuse or not? Om, have you checked this is a hypotenuse? The radius is a natural number. Okay, that is understood. Like this point will be 53, 0. But would 53 be a hypotenuse of any right angle triangle? हर्षवर्धन हाइपोटेन्यूज नहीं है. ओके, ओम का तो आ गया. Not a hypotenuse. Have you checked it by equating it to the Brahma triplet formula? Not a hypotenuse. Okay, let us do that. So how we approach this question? Once we have found out the perfect square, the square root, after that we'll just try to equate it to either of them. Either this. We will check for both. So whenever we get n as a natural number, we are sure it will be a hypotenuse. So let us do that. This means n square will be equal to 2 multiplied by 53 plus 1. Right? This is 107. So n will be square root of 107. And this is an irrational number. We are not able to find the square root. Okay, checking for this one as well. N square over here. I'm so sorry. This is minus 1. But again, doesn't really matter because (106) is not a perfect square. So it's not possible. 105 is not a perfect square. It's not possible. Okay. Coming to this one. So here n square will be equal to 4 multiplied by 53 minus 4. We'll get square root of 208 over here. So again, it's not a perfect square, so not possible. Cool? No, Bharat, we are about to finish. This is the last slide. I want to discuss this question, then of course you can go then. Clear? So what is the answer now? What will be the answer? People say it's 4 solutions. Okay, here comes surprise. It's not 4. It is 12 again. I'll tell you how. This is the last part of this class. We'll be discussing the point where one of you also mentioned what if the largest side is known. When hypotenuse is known, then we'll be using Ramanujan triplets. And that's why I said this is going to blow your mind. So whatever doesn't lie in the Brahma triplets might lie in Ramanujan triplets. And if it doesn't lie there, then of course the answer is 4. Okay? So let us discuss this. For any expression a square plus b square equal to c square, if c is equal to c1 square plus c2 square. So basically what I mean to say that if c can be broken down as a sum of 2 perfect squares, then what happens? Then the triplet will be c2 square minus c1 square 2 times c1 multiplied by c2 and c. So these are the triplets. Look at this and then we can try to find out the solution to the previous problem. The previous problem we had c as 53. Can we break down c? Can we break down 53 as a sum of 2 perfect squares? Is that possible? Of course it is possible. This is 4 plus 49. Now as we can break this, there is a possibility. So 53 is basically 2 square plus 7 square, all right? Comparing with this, 53 is 2 square and 7 square. Now what is the triplet? We get c1 as 2 and c2 as 7. If you put it here, I'll get 7 square minus 2 square, comma 2 multiplied by 2 multiplied by 7 and 53 of course. So 7 square minus 2 square is 45. 2 into 7 is 28 and then we have 53. So the triplet over here will be 45, 28 and 53. So these are the triplets which do not come under the Brahma triplet formula. If Brahma triplet formula doesn't carry all the things, the leftover things where the hypotenuse is known will be found out by Ramanujan triplets. And I know that this is Srinivas Ramanujan. Everybody knows him. One of the greatest mathematical minds India has produced. So by this, we are able to calculate the triplets. And once we have done that, now we know the solution to the previous question is 12. Okay, so 4 possibilities we have got here, 1, 2, 3, and 4. All right. And apart from that, 28, 45 is also possible. 45, 28 is also possible, and all the negative parts are also possible. So we have 12 solutions in total. This is the kind of question in which Brahma triplets and Ramanujan triplets will be applicable. Harshvardhan, right. पहले ब्रह्मा लगाना है, फिर रामानुजन लगाना है. ये क्वेश्चन आपका आ गया, तो आपका ये काफी मुश्किल क्वेश्चन है, बहुत लोग नहीं कर पाते, बट अब आप कर सकते हो. 20-25 सेकंड में यू विल गेट द आंसर. So there are many more applications of this theorem which we'll be discussing once we start doing the geometry or algebra classes. Okay, we'll discuss more such questions. This is basically for the understanding, for clearing your fundamentals and making you realize how important triplets are. That's the man who knew infinity. So that is where I would like to end this session. Thank you. Have a great day. And it's not the weekend. Have a great time. Okay, so I hope here you have been able to surprise yourself with the n number of multitude of applications of triplets in our day-to-day life. We'll discuss more in such coming sessions. Till then, bye-bye, take care. Thank you. It was great talking to you all. And tell me how you liked the application, how you liked the theorem, how you liked the presentation. Tell me in the comments. If you have doubts, ask me in the comments. Thank you. नवीन, मेरा आशीर्वाद हमेशा साथ है. Cool.